Okay.
Good morning. In today's session, we have to study about the DC motor. In previous session, we have studied about the DC motor, EMF generated in DC machine, EMF generated in DC motor. That EMF we are calling as the back EMF. Then we have studied about the torque, which we will get generated in the DC motor and the DC machine. So DC machine means what? We are calling that machine as a DC machine that can be used as a electromechanical energy converter. It means what? It can convert electrical energy into a mechanical or vice versa. That electromechanical converter we are calling as the DC machine. So in our syllabus, we have to study two types of the DC machines, DC motor and the DC generator. DC motor means what? It is the DC machine which can use electrical energy, and at the output we will get the mechanical energy. Then we have seen about the DC generator. DC generator means what? It can convert mechanical energy into a electrical energy. It means what? It will give us the electricity. Then we have seen the construction of the DC machine. We have seen the construction for DC motor and DC generator are same general constructions. Both are having the same constructions. Both are having the stationary part. Both are having the rotationary part. Stationary part means what? The part of the DC machine that are used as a stator, that are not rotating, that are fixed, that we are calling these parts as the stationary part, or we can say this as a stator. If you see, stator will consist of poles which we are used to create the magnetic flux. So we can say commutating poles are used as a stator in the DC generator and the DC motor. Then we have seen rotor. Rotor is nothing but rotationary part. So the rotor of the DC machine will consist of rotationary part that we can call as the armature winding, brushes, commutator, because we know all these things are rotating. If you see these DC machines in which armature, these are nothing but the brushes. I have shown here only the symbol, but already we have studied the structure construction for the DC motor and the DC generator. So what we are saying, the commutator, armature, these brushes all are working as the rotationary part of the DC machine. Then we are study already we have studied about the yoke. Yoke is nothing but it is the outer terminal, outer cover for the DC machine. It can be used as protective. So it will give protective support to the all assembly of DC machine. Then we have seen the EMF. We know when we will give the power supply to the DC machine, at that time there will be generation of magnetic flux. And as we are using armature as a conductor, so if magnetic flux will get introduced and magnetic flux will cut by the conductor, at that time according to Faraday's law EMF will get generated. Then we have studied about the EMF equations. E equal to what we have seen, if we are using DC machine as the DC generator, at that time we are calling EMF as a generated EMF. And if we are using DC machine as a DC motor, at that time EMF will be acted as opposite to the supply voltage. So that EMF we are calling as the back EMF. We are calling that EMF as a back EMF. What is the difference between back EMF and EMF? Back EMF means what? It will behave in opposite direction with the given supply voltage. That we are calling as the back EMF. So we have studied about the equations of the EMF or back EMF. Both are having the same equations. Only what is the difference? What is the difference? There will be change in the direction. मतलब back EMF का जो है equation, it will have the negative sign as compared with the supply voltage. So we have studied about the EMF that will be equal to NP phi upon 60 into Z upon P. N is nothing but speed. P is nothing but number of pole. Then we have seen phi is nothing but fluxes, the flux generated. Then Z is nothing but the total number of armature conductor. We are using as a armature as a conductor. So we have studied all these things. Then we have studied the equations for the torque. Sorry. Okay. Then we have studied about the torque. So torque is nothing but it is also a quantitative measurement for the force that will be caused to rotation of the conductor, and we are using conductor as a armature. So what we can say for the torque? Torque is the measure of the force that will cause to rotation of a armature. So it is the moment of the force that produces change in the rotational motion, and we can calculate torque equal to F into R. F is nothing but force. R is nothing but it is the perpendicular distance. It is the perpendicular distance we can take it is as a radius of object rotating, and we know which object here rotating. Here object is rotating as a armature. So R is nothing but it is the radius of a armature, and then we can take F into R into sine theta. So theta is nothing but it is the angle force by resistor, force by what is this? This is the radius. So what we can say? Theta is nothing but it is the angle between force and the radius. So we can measure torque equal to F into R into sine theta. Then we have studied about the P. P is nothing but mechanical power. Mechanical power, we know it will be related with the torque because mechanical power Pm equal to torque into omega. Omega is nothing but it is the angular, or we can say it is the rotational speed. So we can calculate torque into rotational speed. Rotational speed omega को तुम क्या लिख सकते हो? You can write as a 2 pi n. N is nothing but rotation per minute. So we can calculate torque equal to P into Z into phi into Ia upon 2 pi a. 1 upon 2 pi a you can take as a 0.159 into P Z phi Ia upon a. Again, you can write Pz upon 2 pi a as a constant K. So we can write torque equal to K into phi a. So where K will be P into Z upon 2 pi a. All these things already we have studied in the previous session. Now we have to study about the types of DC motor. So what we are saying here, DC motor we can use as a electromechanical energy converter. So there are different types of the DC motor as the name given here. Separately excited DC motor, and other type is the self-excited DC motor. Here we have to study about the separately excited and the self-excited. Okay, you can see here. As the name signifies, here if you see DC supply is individually given to the field winding. Here we are giving our DC supply individually to the field winding. We are not giving here supply directly to the field winding and the DC motor. So what we can say, if there is a separately excited DC motor, that time here we are supposed to give DC supply to the field winding separately. That circuit diagram is called as the separately excited DC motor. Here we can see DC supply we are giving here individually to the field winding which we are using with the armature. We are not giving armature and field winding directly DC supply. But here if you see the self-excited DC motor, here we can give DC supply to the armature. हम यहाँ क्या कर सकते हैं? In self-excited, we can give here DC supply to the DC motor. At that time, here field winding will get DC supply. But if there is a separately excited DC motor, at that time, we are supposed to give DC supply individually, privately to the field winding. But if there is a self-excited DC motor, that time in this type of motor, current in the winding is supplied by motor, or we can say that is a motor or it can be a generator. If it is a self-excited, at that time what we are supposed to give? We are supposed to give that DC supply to this motor. And ये जो coil है, ये जो motor है, when we will give DC supply to the motor, that time current will be provided to the field winding by that DC motor, or it can be given to that field winding itself. That time we can say that type of DC motor as a self-excited. So in self-excited there are different types of the DC motor. Shunt wound DC motor, what will be the shunt wound? Here if we are giving the supply, that will be in shunt with respect to the DC motor. If there is a current series wound, or we can say series motor, at that time here when you will give the input supply, at that time you can give input supply that will be in series with that DC motor, and DC motor will give current to the field winding. Compound wound, here we can use any type of shunt or series in the compound self-excited DC motor. We can see here one by one. You can see here. Here firstly we have to see series self-excited DC motor. In that we are supposed to see three types of shunt wound, series and compound wound. So shunt wound means what? We can say here, if you see when we are giving the DC supply, at that time you can see here armature winding is in series, is in shunt. Shunt means parallel. We can say shunt or a parallel. You can see here that winding is in parallel with armature. You can see the construction diagram also. If you can see the construction diagram, you can see here this is the outer covering. We are calling ये gray color जो है dark black, we can say it is as a yoke. In that we are using two poles, one pole, second pole. On that we are doing the field winding. Here if you see, these are nothing but the armature. In this we are using here commutator, on which we are putting their air dot for the cooling purpose. So here we can see this field winding. It's this field winding. You can see here how I have taken this field winding. We can take this field winding in a parallel. We can say it is a shunt field, or we can say parallel. So if in this type of DC motor, if field winding is in parallel with the DC motor, or it is in parallel with the armature, that time we can say that type of DC motor as a self-excited shunt wound DC motor, because here if you see the construction is look like a shunt, it will look like a parallel, because here field winding is connected in shunt with the armature. यहाँ पे क्या है, ये जो winding है, we are taking winding as a inductor, because we know winding we can make by using the inductor. We can call coil as a shunt field winding. हम क्या कर सकते हैं, coil को field winding बोल सकते हैं, because here we are using inductor as a field winding, because it is a, if we are using here armature as a conductor, at that time it will be cut by magnetic flux and EMF will get introduced. So here by using the DC motor, by using the DC generator, what we are supposed to do? We are supposed to create the EMF, or we are supposed to use that EMF. So here this is the basic circuit diagram, or you can see this is the systematic diagram how it will look like. So it will be look like this. Here if you see, armature will be connected in parallel with the field winding. Now when we will give the power supply, when you will give here power supply, at that time what will happen, some amount of current will flow through this armature, and some amount of current will flow through this field winding. If is nothing but the amount of current which will flow through field winding. F is for the field and A is for the armature. So what will happen, when you will give our main power supply to that DC motor, at that time some amount of current will flow through the armature and some amount of current will flow through the field winding, and we are calling that field winding as a shunt field winding because it is in parallel with the DC motor. It is parallel with the armature winding. So here total current will be addition of armature current and the current which is flowing through the field winding. So I have taken here IT equal to RA plus IF. Now what we are supposed to derive the equation, you can see here. What we are supposed to do here, I have taken the same diagram here. वही diagram मैंने फिर से ली है. You can see here the same diagram, the same equations I am writing again. So you can see here. When you will give the power supply, at that time the current, voltage and power equation we are supposed to derive for the self-excited DC motor. So here if you apply the KCL. So according to KCL is nothing but Kirchhoff's current law. It will be used to derive the value of current. Kirchhoff is one scientist. He has derived the two laws. These are nothing but Kirchhoff voltage law and the Kirchhoff current law. So Kirchhoff current law states that at any node, incoming current is equal to the outgoing current. Or we can take statement in different way, like algebraic summation of a current at any node will be 0. So what does mean by node? If at any point in the electronic circuit or electrical circuit, because EMF is used in electronic as well as in electrical engineering. So what we can say, if at any point in the electrical circuit more than or equal to two components are connected, at that time we are calling that point as a node. So you can see here this point जहाँ पे मैंने मेरा cursor रखा है, at point you can see here, at that point field winding का एक terminal connected है, at this point DC motor मतलब armature connected है, at this point जो हम power supply दे रहे हैं उसका भी connection है. It means what here, we can call this point as a node. So according to KCL, we can apply here KCL for this node. So if this is a node, you can say here total current will go to this side and some amount of current will flow to armature, some amount of current will flow through field winding. So we can take total current equal to IA plus IF, and you are taking the summation. So you can take, if you see this is the node, if you are taking incoming as a positive, that time outgoing you can take as a negative. So you can take IT minus IA minus IF equal to 0, meaning 8. You can write here IT equal to IA plus IF. Or you can take incoming current at any node equal to outgoing. So incoming, you can see here, incoming is nothing but only total current. So I have written here IT to the left side. So equal to outgoing current at this node. So you can see here, outgoing is nothing but जो current वहाँ से जा रहा है. You can see here, IA and IF are going from this total current to the armature and the field winding. So I can take IT equal to IA plus IF. So IA is nothing but current flowing through the armature. IF is nothing but the field current or field winding current. Or we are calling that field winding as a shunt winding. So we can say that current as a shunt current. We can say shunt current, you can say field current, or you can say the parallel current. So you can take IF if you are calling this field winding as a RSH. RS is nothing but shunt shunt fielding, shunt resistor, shunt impedance. SH is nothing but we are using that SH abbreviations for the shunt because it is in parallel with the armature. So we can call this as the shunt current, the current flowing through this RSS. So what we can take here? Again, we can apply here KVL. So at any node, we can apply KCL. And if there is a loop, so what does mean by loop? If there are two or more than two components are connected in a manner like if incoming current is having the path to make that loop as a closed loop and it will have the directions to go return back. If you see this circuit diagram. If you see this circuit diagram, only for the armature and the shunt field winding. If you see, this current will flow, IF will flow from this side and again from motor it will go to again field winding. It means what? It is these two components are making a loop because these are having the closed path. If you see this, it is not a loop. It is not a closed loop, it is a open loop because जो करंट फ्लो हो रहा है उसको रिटर्न जाने के लिए यहाँ पे डायरेक्शंस नहीं है, उसको पाथ नहीं है. So what we can say here, to derive the equations for the voltage we can apply KVL for this loop, or we can say we can apply KVL to the field winding circuit. If you are applying the KVL according to the KVL, according to the KVL law, Kirchhoff's voltage law, the algebraic summation of a potential drop between every component for closed loop will be equal to 0. It means what? We are supposed to derive the voltage which will be appeared across each element. Again, we are supposed to take the algebraic summation and that algebraic summation will be equal to 0. Or we can take KVL as potential rise equal to potential drop. Matlab, the increase in the potential and the decrease in the potential. You can take potential drop equal to potential rise. These concepts you will not be required that much. Only we are using in this circuit to derive the equations for voltage and current. Just because of this reason, I am giving you short some ideas regarding KVL and KCL. Otherwise, you guys are not supposed to solve the numericals on the KVL and KCL. There will be some numericals on the EMF and torque. To derive the equations for EMF value, sometimes they will give the DC motor, they will give the number of fluxes, they will give the speed that will be in rotation per minute or that will be in rotation per second. So these things are depending on you, how you are converting the equations from rotation per minute to rotation per second. If the value is given in the rotation per minute and you are supposed to calculate in the rotation per second, at that time you are supposed to multiply by 60. जो इक्वेशंस हमने ईएमएफ के देखे हैं, बैक ईएमएफ का देखा है, टॉर्क का देखा है, ऑन दिस थिंग्स you guys are supposed to solve the numerical. Okay, so here in this syllabus what we have to see here, we are applying here KVL to whom? To this field circuit. We are applying KVL. So KVL क्या बोलता है? Algebraic summation of a voltage for this closed loop will be 0. But firstly, according to the Ohm's law क्या बोलता है? If there is a voltage, if there is a current and if there is a resistance, that time according to the Ohm's law we can derive the relations for voltage, current and resistor. We can derive V equal to IR. So firstly, if you are deriving the equations for this voltage, firstly, if you are deriving the equations for this voltage, if you see the number of components are connected in parallel at that time, potential drop or voltage that will be flow across each element will be same. If the components are connected in parallel and if the components are connected in series, at that time current flowing through each and every element will be same. Mechanical students, in your syllabus we are supposed to study electrical as well as electronics. Both subjects we are having in only one unit. So this subject is not that much simple. ऑर्डिनो प्रोग्रामिंग इलेक्ट्रॉनिक्स का सम पार्ट हम देख चुके हैं, अभी हम इलेक्ट्रिकल पढ़ रहे हैं. उसके बाद अगेन इन योर फिफ्थ सिक्स यूनिट अगेन यू आर सपोज टू स्टडी अबाउट द इंटरफेसिंग ऑफ DAC, ADC. These things are again of the electronics. So you guys are supposed to join each and every class, and you are supposed to do revise on these PPTs by using my videos and my given notes. So here you can see here when we are applying the KVL, we will get equations for the voltage, and what we are saying, if the components are in parallel, the voltage will be same for each and every element. So you can see here when you will give the power supply, जब यहाँ पे मैं voltage दूंगी, power supply, voltage, battery all are having the same unit, all are having the same name, they are signifying the same meaning. So when you will give here power supply, what will happen, the potential drop, some will go to this and some will go to, and if these components are parallel, you can see here we are calling this circuit as a shunt motor circuit, because फील्ड वाइंडिंग जो है ये डीसी मोटर के साथ पैरेलल में है. डीसी मोटर इज नथिंग बट हियर armature, we can say here field winding is in parallel with armature, the potential drop will be same, so we can calculate voltage equal to IR. So I is nothing but we are calling that current is nothing but IF, or we can say ISH. Both are IF or ISH, both are having the same meaning. ISH means shunt current and IF means current flowing through the field winding. So I can take here IF or ISH into the value of that impedance. So here we are having the value of impedance as a RSH. So we can take here V equal to ISH into RSH. I am giving here number because we are supposed to derive the equations for voltage, current for the whole circuit. So here you will get according to the Ohm's law V equal to IR ISH into RSH. You can write here. Now when you are applying here KVL, when you are applying here KVL for this closed circuit, what will happen? Total voltage will be equal to, some potential drop will go to this, some will go to this. So what we can say here, the potential drop will be generated across DC motor. If that is a DC motor, तो EMF जो जनरेट होता है उसको हम क्या बोलते हैं, बैक EMF. We are calling that EMF as a back EMF. In this language, electrical, EMF, voltage, power supply, voltage drop, all are having the same unit, all are having the same meaning. So we can take here the value of voltage which will be appeared across this DC motor or across this armature will be EB. So I can take here EB plus which is flowing through this. We can write ISH into RSH, or you can write here IA into RA. I can take here IA into RA. So you can see here again what will happen. I have written the same equation again. You can see here. Now what we are supposed to do? What we have done here, we are applying the KVL and you will get the equations for the voltage. That will be EB. This is nothing but back EMF. EB, then voltage which will be appeared across armature. So we know the current flowing through the armature is IA, the amount of resistance. So we can take armature ka resistance, you can take RA. So you will get here the for armature winding, you will get the equations V equal to EB plus IA RA. Now we are suppose हमने करंट का इक्वेशन निकाला है, हमने वोल्टेज का इक्वेशन निकाला है, हमने वोल्टेज का इक्वेशंस we have derived for the this shunt field winding also. Now we are supposed to derive equations for the power. So we know power equal to V into I. The power equations will be the mechanical power which will be developed, which will be generated. The losses in the armature winding. This is also we are calling as the power loss. Again, the losses which will be across this field winding. So the incoming power, input power, we can take as a V into I. This is nothing but total current. Equal to mechanical power. Mechanical power we are taking as a PM. We have already studied these things in the torque equations. PM equal to, already we have studied. PM equal to हमने टॉर्क का इक्वेशंस देखा है. उसके बाद Pm इक्वल टू W इंटू टी, वी हैव सीन 2 पाई n into torque. So we can see here, firstly what we can do here, we are supposed to derive the equations for the power for this whole DC motor. So that will be the power that will be developed, the losses in the armature and the losses in the field winding. So we can take the mechanical power that is developed as the PM plus the power which will be lost across the armature. We can take IA square into RA, or you can take VA into RA. And VA को मैं क्या लिख सकती हूँ, IA RA. That's why I have written here IA square into RA. फिर यहाँ का पावर क्या है, V इंटू आर. V को क्यों क्या लिख सकते हो तुम, I इंटू आर. तो I स्क्वेयर RSH. These equations you guys are supposed to do practice by yourself on a notebook. That time you will get the things. ये वर्चुअली मैं बता रही हूँ, तुम्हें इतने आसानी से समझ में नहीं आएगा एक के बाद इक्वेशंस कैसे आ रहे हैं. यू गाइज आर सपोज टू डू प्रैक्टिस एट योर होम. ओके, सो व्हाट वी कैन से हियर, दिस इज द पावर लॉस अक्रॉस द आर्मेचर, दिस इज द पावर लॉस across the shunt winding or the field winding, and it is the power generated, or we can say it is the mechanical power. But we know from equations 2 we can write RSH equal to, second equation क्या था हमारा, V equal to ISH into RSH. From this equation I can write RSH equal to V upon ISH. So what I can do, I can put the value of RSH in this equation. What I can put here, V upon ISH. So what will happen here, if you are putting this value, your equation will become V into I, PM as it is, I square RA as it is, and here RSH को तुम क्या लिख रहे हो, V upon ISH. ISH will get cancel 1 and you will get V into ISH. But now again what we can do here, you can convert this equation, you can rearrange these equations in the form of mechanical power, because we are supposed to derive here equations for the power. So what we can do here, मैं ये इक्वेशन को रीअरेंज करके क्या कर रही हूँ, पीएम के लिए लिख रही हूँ. सो इफ यू आर रीअरेंजिंग एंड राइटिंग दिस इक्वेशंस फॉर द पीएम, you will get these equations. Again, if you see in these equations, V is common in VI and IS, V into ISH. मैंने V कॉमन लिखा है, I minus ISH I have written, minus I square RA as it is. But we know from our first equations we are having IT equal to IA plus IF. ये A कैपिटल लिखा है या फिर स्मॉल लिखा है, दिस इज नथिंग बट करंट फ्लोइंग थ्रू द आर्मेचर. So what we can do here, I can write here I equal to IA plus ISH, because the current flowing through the armature and current flowing through the field winding. So again I can convert these equations, I को मैं IA के फॉर्म में कन्वर्ट कर सकती हूँ. IA के फॉर्म में क्या हो जाएगा इक्वेशंस, IA इक्वल टू I माइनस ISH. So again what we can do here, I can write the value for the IA. IA जो है यहाँ पे मैं वैल्यू लिख सकती हूँ. So again you can write here I minus ISH को मैंने क्या लिख दिया, IA. So your equation will become PM V into IA minus IA square RA. If you see IA is common, again I can write here IA common in bracket V minus IA RA. You can see here again I am taking the same diagram, I am taking the same equations, PM equal to, मैंने same equation फिर से लिखा है यहाँ पे IA common in bracket V minus IA RA. But our from equation, third equation, when we are applying the KVL and we are calculating the voltage which will be appeared across this armature, what our equation is, V equal to EB plus IA RA. I can convert these equations in the form of EB. If you are converting, you will get EB equal to V minus IA RA. We are having here V minus IA RA. मैं उसकी जगह क्या लिख सकती हूँ, EB. So you will get here PM equal to IA into EB. If you see these equations already we have studied in the torque equations, I will show you. Power. When we are calculating the power equation, at that time also what we have seen, we are supposed to calculate the mechanical power developed that is in the armature. we can take as a IA into EB. But we know mechanical power will be can taken as a torque into speed. This is nothing but the angular speed. We have already seen. तो यही equations हमें अभी मिला है. You can see here. We get the equations for the power, that is nothing but हाँ ये यहाँ पे फिफ्थ इक्वेशन PM इक्वल टू IA इंटू EB. I is nothing but current flowing through the armature. EB is nothing but back EMF. So multiplying equations 3 by IA. What we can do here? Our third equation is nothing but V equal to EB plus IA RE. If you are multiplying both sides of the equations for the same number, there will be no change. We can convert V into IA plus PM, क्योंकि EB into IA हो जाएगा तो मैं इसको PM लिख सकती हूँ. IA square RE. But we know V into IA is nothing but electrical power. So your equations will be power equal to PM plus I square RA. You can see here. I have not written here the equation. Okay. So total power is equal to PM plus, this is nothing but the mechanical power developed, plus this is the electrical power supplied by the armature winding, equal to mechanical power developed and the power that is appeared, that is lost across the armature, that will be IA square RT. So this is the equations for the power for the self-excited, and which type of? The shunt, because here if you see field winding is in parallel with the DC motor. Here we have finished about the shunt type of DC motor. Here we have to see the concept of load torque, that we will see in the next session. So here you can see here in today's session we have studied about the types of DC motor, in which we have to see separately excited and the self-excited. Separately means if we are giving power supply individually to the field winding, that time we are calling that as the separately excited. And if the power supply we are giving to the armature and the power will go to the field winding by the armature winding, that time we are calling that as a self-excited, in which we are supposed to study shunt motor, series motor and the compound motor. So here we can see the self-excited, in which we are giving here power supply to the DC motor and the armature winding will give power to the field winding. This is the construction diagram for the self-excited DC motor. Then we have studied how to derive the equations for the current, power and the voltage. By using the KCL, we can get the equations for current. By using the KVL, you will get the equations for the voltage, and we can calculate by using the current equations and the voltage. We can calculate the power generated in the DC motor. You will get the equations. Total power will be equal to mechanical power plus power loss across the DC motor. Here we have finished about the self-excited shunt motor. Now I am taking your attendance. If anyone is facing any issue, you can ask me. Okay, thank you. If you guys have not finished your assignment, then please finish your assignment and submit. Okay, thank you. You guys can leave now. If anyone is facing any issue, you can ask.